In this lecture, you'll learn about route summarization and the default route. On the slide here, this is a summary of what we configured in the last lecture. So on R1, we don't need to enter routes for its directly connected networks. They were automatically put into the routing table when we configured our IP addresses, but we do need to configure routes for anywhere that the router is not directly attached to. So we've got routes to the 10.1.2 network, the 10.1.1 network, and the 10.1.0 network, which are all available behind R2. But it is actually possible to summarize that into one route. For static routing, summary routes lessen the administrative overhead, because if you've got less routes to configure, that lessens the workload on you. It also lessens the memory usage on the routers. The less routes there are in the routing table, the less memory it's going to take up. And you see in the example here, we're going down from 3 routes to 1 route, which isn't much of a difference, but in large environments, it can make a big difference. So the way we do the summary is on R1, rather than having the 3 routes, let's go back a slide. So you saw the traditional way of doing it. I've got a separate route for the 10.1.0 network, the 10.1.1 network, and the 10.1.2 network, but they're all pointing at the same next hop. Well, when our subnets are in contiguous ranges like this, following on one from the other, it's usually possible to summarize them, which is what we've done here. So rather than having separate routes for 10.1.0, 10.1.1, and 10.1.2, which are all with a /24, I've configured one route for 10.1.0.0 with a subnet mask of 255.255.0.0. So this route will be good for all subnets that begin with 10.1. So 10.1.0, 10.1.1, 10.1.2, etc. And they're all reachable through 10.0.0.2. So that's how we configure summarization. Now, in the example here, I summarized at the classful boundary for a class B address, which is going to cover our routes all the way from 10.1.0 to 10.1.255, which is a pretty big range. Maybe we don't want to have all of those subnets available behind R2. Maybe some of them that are still within 10.1 are available through a different path. So you can be a bit tighter with your summarization, like you see in the example here. So rather than saying IP route 10.1.0.0 and then 255.255.0.0, here I've said IP route 10.1.0.0, and then I've used a subnet mask of 255.255.252.0, and again pointing at R2 at 10.0.0.2. To see what's happening here, if you remember back to the subnetting section, I know that it's definitely going to begin with 255.255 because all of the subnets I'm pointing at begin with 10.1. It's on the next octet that I'm going to be summarizing. Here, I just want to summarize 10.1.0 to 10.1.3. And I've used the value of 252. You know the way that the subnetting goes up? It goes up from 252 to 254 and then 255. So that means that I've used 2 bits there. 2 bits gives us 4 possible values. That's where we get the 0 to the 3 from. Okay, so that's how we configure our summary routes. Next thing is the longest prefix match. So this is something that can come up, particularly when you do have summary routes. So in the example here, it's the same topology before, but we've now also added R5. The link from R1 to R5 is on the 10.0.3 network, and that is directly connected. There's also a subnet of 10.1.3, which is running from R4 to R5. So if I just left it with my route of IP route 10.1.0.0, 255.255.0.0, 10.0.0.2, you see the path that traffic would take to get to R5 at 10.1.3.2 or anything on the 10.1.3 network is it would go from R1 to R2 to R3 to R4 and then to R5, because my route is pointing at 10.0.0.2. Now, I do want traffic for all of the 10.1 networks, like 10.1.0 and 10.1.1, and maybe I've got a 10.1.4 also behind R4 here. I want all of that traffic to go via R2. But if I'm sending traffic to the 10.1.3 subnet, I don't want it to go along the top path. I want it to go along the bottom path via R5, because that's a more direct route. So I'm also going to add a route for that as well, which is IP route 10.1.3.0, 255.255.255.0, 10.0.3.2. Now, you see if I send traffic to 10.1.1, well, that only matches one of these routes, which is the top one. Obviously, it doesn't match 10.1.3, so it will take the top route and it will go via R2 at 10.0.0.2. If I send traffic to 10.1.3, that matches the top route, and it also matches the bottom route as well, and both of these are in the routing table. So which one is the router going to take? It takes the one with the longest prefix. The second route has got a prefix of 255.255.255. The first route has got 255.255.0.0, so the second route is a longest prefix. So all traffic for the 10.1 networks will go via R2, unless it's for 10.1.3, which will go via R5, which is exactly what I want to happen. Another way of saying the longest prefix match, and a more intuitive way of thinking about it, is whichever is the most specific route is going to win. Okay, so that's what happens when you have overlapping routes, but what if you've got multiple routes for the exact same destination, meaning the same destination IP address and the same prefix as well? In that case, the router will load balance the traffic over those routes. So you see the example here. On R1, we've got a couple of routes, and they're both going to the exact same destination. They're both for 10.1.0.0 and a subnet mask of 255.255.0.0. One route has got the next hop of 10.0.0.2. The other route has got the next hop of 10.0.3.2. So in this case, they're both exactly the same. Then the router will load balance traffic over the two different next hops. Okay, last thing to tell you about in this lecture is the default gateway, which shows up when you do a show IP route as the gateway of last resort. So in the topology here, it's the same example as the last slide, but let's say that we also have a route going out to the internet. So R1 is connected to the internet. We're using a public IP address there. On the R1 side, it's 203.0.113.1, and on the internet side, it's 203.0.113.2 at our service provider. So to add a route going out to everywhere else that we haven't specifically had a route for elsewhere, it is 0.0.0.0. 0.0.0.0. So our full command is IP route 0.0.0.0, 0.0.0.0 going to the next hop at our service provider of 203.0.113.2. So a default route is a catch-all for any traffic that doesn't match one of our more specific routes. So in our example here, if we send traffic to the 10.1.1 network, that will match the top route going to 10.1.0.0, and it will also match the bottom route going to 0.0.0.0, which is everything. The top route is more specific, so that will be sent to R2 at 10.0.0.2. If we send traffic to the 10.1.3 network, that will match all three routes, but it's the middle route which is most specific, so that will be sent to R5 at 10.0.3.2. If we send traffic out to the internet at 50.50.50.50, it doesn't match the first two routes, it only matches the last route, so that will be sent out to the internet. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.